If humans are looking for life on another planet in our solar system, or even beyond, it will most likely be something microscopic, like bacteria or archaea. To better understand what life would need to survive on another planet, astrobiologists study microorganisms on Earth that live in unusual conditions. These conditions are things like very high or low temperatures, high or low pressure, desiccation, meaning lack of water, and high levels of radiation, among other things. The organisms that live in these unusual conditions are called extremophiles. Today, we will focus on one category of extremophiles called thermophiles that thrive in high temperatures and how they are adapted to live in these warm environments. Sometimes topics in science can seem intimidating to learn, but I find that the principles often mimic something else that we use in our daily lives. For instance, a hobby. I am going to show you how I use principles in karate to remember how thermophiles are adapted to live in high temperatures. A couple of quick notes before I begin. My style of karate is from Okinawa and is called Matsubayashi Ryu. I've been practicing for 4 years, but I am far from being an expert. Secondly, karate should only be used for self-defense purposes. We never encourage violence unless there is real danger. Strategy 1. Reinforce membrane. Cell membranes are important because they act as gatekeepers for the cell, moving things in or keeping them out as necessary. High heat can break chemical bonds in the membrane and make the cell leaky. For this reason, thermophiles sometimes have reinforced membranes to make them stronger. This can be accomplished by fused lipid membrane tails in archaea or by adding molecules called hopanoids to reinforce the membrane in bacteria. In karate, this is comparable to a reinforced block. I'll show you an example. A regular middle block looks like this. You can see that I am deflecting the punch easily with one arm. Sometimes, when deflecting a very strong strike, you have to reinforce the blocking arm with your other arm. It is easier for me to deflect the strong force. This is similar to fused lipid tails of the membrane or reinforcing the membrane with hopanoids. Strategy 2. Adapt existing proteins. Just like the cell membrane, proteins in the cell are likely to fall apart or melt in the high heat, so thermophiles have a way to make them more stable. Proteins are made of amino acids. The amino acids that are hydrophobic or don't like water fold to the inside of the protein so that they are protected. By having more hydrophobic amino acids, the proteins become more compact and stable. This can also be accomplished by incorporating more bonds and chemical interactions, like disulfide bonds or salt bridges, between the different parts of the protein. Lastly, in comparison to other microbial organisms, thermophiles decrease the number of cavities in their proteins and shorten loops of amino acids that are exposed. Being compact is very important when sparring with an opponent. You must protect the most vulnerable parts of your body, like the head, the core of your body, your ribs, and your kidneys. You must also minimize the amount of time your arms and legs are outstretched because it leaves those vulnerable points open. This is comparable to how thermophiles have compact proteins with minimal surface area to combat the heat. Strategy 3. Reduce or eliminate cofactors. Enzymes are a class of proteins that catalyze biochemical reactions that are important to sustain life. Cofactors are molecules that are needed for those enzymes to function. Many important cofactors used in organisms that prefer what humans would consider comfortable temperatures are sensitive to heat. Instead of optimizing these cofactors for high temperatures, thermophiles often find a way to get around using them entirely. Just as you would use up a lot of energy in the heat, physically fighting another person uses a lot of energy. Some martial arts styles use large, sweeping movements. In karate, we are taught to use the minimal amount of movement and force necessary. This conserves energy and will help you last longer in a fight. As you can see, I only block this strike to where it moves just past my head. Any more force on my part would be wasted movement and energy. Strategy 4. DNA stabilization. DNA is like the recipe for life. Without it, we can't make the necessary proteins to function. The bonds in DNA can break when the temperature becomes too high, which would be disastrous for the microbe. Here is one example of how thermophile DNA can be different from the DNA of other microbes. DNA is made up of pieces called nucleotides, which are differentiated by their nitrogenous base component. These bases are adenine, A, guanine, G, thymine, T, and cytosine, C. In double-stranded DNA, A always pairs with T, and G always pairs with C. The A and T pair is connected by 2 hydrogen bonds, and the G and C pair is connected by 3. Having more bonds makes DNA with more GC pairs more stable. Thermophiles tend to have more GC content in the portions of their DNA that make proteins than other microbes do. In karate, we are taught that our stability starts with a good stance. It is the base of how we generate our power. See what I did there? Many of our stances are wider than a resting position because a wider stance improves your balance. Here is an example. In this general stance, it is pretty easy for Kathleen to push me over. If I assume a broad stance, she has much more difficulty. So in both karate and thermophile DNA, the base composition is important for stability. Strategy 5. Salt concentration. Another way that some microbes protect their DNA at high temperatures is to ingest or increase the production of potassium chloride and magnesium chloride. These salts help stabilize the DNA helix by reducing the repulsion between the 2 negatively charged strands. In karate, and really when you're doing any amount of vigorous exercise, you may need to supplement additional salts into your diet. This is why many popular sports drinks contain salts. Salts help us properly use our muscles, conduct nerve impulses, and regulate fluid volumes in our bodies. Without replacing the salts our body sweats out, we can develop muscle cramps. Strategy 6. Specialized proteins. In the heat, proteins sometimes become denatured, meaning they unfold and become non-functional. A special group of proteins called heat shock proteins target these unfolded proteins and either aid in their destruction or assist in refolding them so that they are functional again. Heat shock proteins prevent non-functional proteins from collecting or embedding into the cell membrane, which would cause leaky or destabilized membranes. We talked about why this would be dangerous in the membrane reinforcement strategy. In addition, when an organism is exposed to high, nearly lethal temperatures and it produces heat shock proteins, it is more likely to survive lethal temperatures. This is called acquired thermotolerance. While all organisms have heat shock proteins, thermophiles often have a relatively larger proportion of them. This is a kata, or an individual exercise where you follow a prescribed set of self-defense moves while envisioning your attackers. In the video, I am performing a kata called Pinan Yodan. In karate, we train in self-defense in the hope that we never need to use these fighting techniques. The goal is that, in a dangerous situation, if you have to use your karate to save yourself, your body will remember the movements you practiced over and over. Over time, your exposure to different self-defense techniques make you more likely to survive a dangerous encounter. Just like thermophiles produce specialized proteins, karate practitioners learn specialized movements. Prior exposure to near-lethal temperatures makes thermophiles more likely to survive lethal temperatures. Prior exposure to attacks in training make a karate practitioner more likely to survive a physical attack. In summary, we discussed 6 adaptations that thermophiles use to thrive in high-heat environments. Reinforced membranes, adapting existing proteins, reducing or eliminating cofactors, DNA stabilization, altering intracellular salt concentrations, and producing specialized proteins. I hope that these parallels in karate help you remember these strategies and encourage you to look to your daily life to find parallels with science.